Hello, my name is Matthew Geary, and here's my Stata problem set number 8 presentation. So our problem question is, what are the factors that contribute to changes in the price of several properties? We had a list of them, and we were given several variables, of which I'll go into what is the X and what is the Y variable shortly. We had things such as zip code, sold price, beds, price age, zip code, sale month, sale year, living area, bath, lot area, and year built. And so this is just showing on the N right here is the number of observations. Then we have the mean for each. For example, the mean of the sold price is just about 745,000. There's about 3.3 beds, about 58 for the price age variable, and so on and so forth. And we can look at the min and the max as well of what the low sold price is, what the highest sold price is. And the sales month, we look down here, it's between January and March alone in 2016. And yeah, keep going. And so our Y variable is going to be the log of price age, which is a variable we were told to create. And our X variables are going to be living area, PR age, beds, bath, lot area, sale month, and zip code. And we'll get into it in a little, but essentially we are going to have to take out some of those variables due to multicollinearity. And so looking at the correlation matrix and the VIF test right here, we can see that there's multicollinearity with living area and LN price, baths, LN price, living area and baths is a very high one, beds and living area, and finally beds and baths. And if we look at the VIF, none of these numbers are above 5. So that means that there's no multicollinearity shown there particularly. And the number we were using over here with the correlation matrix was 0.5 and greater, preferably 0.6 and greater, actually. And so the highest ones that we see had a lot of issues were baths and living area. And so we decided to take those out, start with those, and try to run our regression over again and get the VIF and the correlation matrix again and see if there's multicollinearity. And we figured out that the best option was to take out both baths as well as living area. And so we look here, and after taking those out, we get an adjusted R squared that is 0.687, which is a little lower than, well, you leave some of those in, but you can't have multicollinearity, so you have to take them out. So the adjusted R squared right here just says 0.687, which means that our regression shows about 68% of the variation. And there's 4,606 variables. And you can interpret these variables over here pretty easily. And so a change, like a 1 unit change in the LN price is associated with a 1 unit change in the PR age is associated with a 0.006 decrease in PR age or in LNPR. And then if you want to go on to beds as well, you can do the same thing as a 1 unit decrease in beds is associated with 0.135 increase in the LNPR. And finally, we had a fixed heteroscedasticity. And so to do that, we did K density plots, which was trying to show the several variables against the normal distribution. And so we look here and we have on the far left, we have PR age, then we have beds in the middle, and we have lot area on the right side. For each, unfortunately, we only have this many variables left because you can't do K density for I sales and iZip, even though you leave both of those into the regression. And so you only have these left. And so based off of these, we can see these left two specifically. The plots do not really follow the normal distribution, so we are going to have to log those specifically. And the only one that does is the far right run, the lot area. It follows it pretty well, and we're going to keep it as is. And that is my presentation. Thank you.